Hello everyone, in this video I'll be covering the 8th program of Data Structure Laboratory, that is to design, develop and implement a menu driven program in C for the following operations on Doubly Linked List of employee data with fields SSN, name, department, designation, salary, phone number. First of all, we need to do these functions, or we need to implement these functions in the program. What are those? Let's see. So first of all, create a DLL of an employee's data by using end insertion, and next display the status of DLL and count the number of nodes in it. Next, we need to perform insertion and deletion at end of DLL, as well as insertion and deletion at front of DLL. And also we need to demonstrate how this DLL can be used as doubly ended queue. And coming to the ETH part, that is demonstrate either you can use the functions available in the program and you can show how exactly doubly ended queue can be working, or in this program I have implemented doubly ended queue to show what are the operations that can be comes under doubly ended queue. As the name suggests, it is a queue with a double ended, so both the ends are open, so we can perform insertion and deletion at both the ends. Next, what is doubly linked list? Let me tell that. So when it comes to doubly linked list, name itself says there are two links. Name itself says there are two links. If this is a node of a linked list, there are two links. What are those? Here you have a data field, and then you have two links, that is L link, left link or right link, and you can name this as anyhow. Sometimes we refer it as previous and next, whichever name is suitable for your program you can keep it. Okay, and what's the meaning of these links? L link or a previous node, previous link is going to point to the previous node. That means it is going to hold the address of the previous node. When it comes to R link or a next link, is going to hold the address of the next node. So that's how that's why the name doubly linked list. Whereas in case of singly linked list, you can find only one link, and that link is going to hold the address of the next node. Here, in both ways, we can communicate in a reverse, in a forward direction as well as reverse direction. That is the advantage over a singly linked list. So f the function is exit. Okay. After that, description. Let's understand. That's what I've explained. The description, like how exactly we are going to perform these operations, that we'll see in the implementation part of the program. Okay. Before that, coming to linked list, as I said, there are many nodes in the linked list. There are many nodes in the doubly linked list, and what happens? There are two links everywhere, but when it comes to the first node, this link, that is left link of the first node, is null because there is no previous node. When it comes to the last node, the right link of the last node is null because as there is no next node present in the doubly linked list. Okay, that is what doubly linked list, and you need to perform the several operations like insertion, deletion at the end and front in case of the programs in this program. Coming to the program, there are header files in it. So the two header files that is required for the program are stdlib.h and stdio.h. Then I have declared the variables as well as function declaration. I have made the variable declaration as well as function declaration. Function declaration in the sense the prototype. And suppose if your function definition is before its usage, if a function definition is before its usage, then no need to define declare the functions like this. That is, no need to write the prototype of a function. Now let's understand each one of these. First of all, why am I using n, variable n? N is going to hold the number of nodes that I am going to create when I call a create function. It's going to tell you, or it's going to read the number of nodes that I want to create in case of create function. Then what about create function? Create function, as I said, it's going to create the nodes for a doubly linked list, and using insert end operation. Next we have insert front. Insert front in the sense, we have a doubly linked list, and if it does not exist for the first time, then your first node itself is the last node. That means there is only one node in the single list. If there are more nodes in the linked list, then what you have to do, insert front is like you create the node and just attach it to the existing linked list. Okay, and as I said, since the function what you are performing is insert front, you need to attach the node to the front, and in case of insert end, you need to attach the node to the end. And also delete front and delete end, you have to do delete. In case of delete front and delete front, you need to check that whether the list is empty. If list is empty, then you have to display that there are no elements. Otherwise you can delete. If you call delete front, it can, if suppose the list exists, then it has to delete from the end. If you call delete end function, then it has to delete the last node from the list. Okay. So next is display. Display is going to display the status of nodes in the linked list. That means status of nodes in the sense, each node is going to hold employee information. So all employee information is displayed, as well as it is also going to tell that how many nodes you have created, the number of nodes, status of nodes, and the number of nodes. Next, as I said, I have here implemented a doubly ended queue. So that is defined under the function queue. Next, before writing the definition, or before using before creating the linked list, you need to create a structure of a node. How does each node, or what is the each node is going to carry. That means we need to create a structure for a node. As I said, structure is nothing but it is going to tell what contents are going to be there in the node. So as I said, each node is going to hold employee information. What's the information? Everything all employee information I have specified under character. Okay, that's why. And these can be of because the contents can be of different type. That's why the best, and all these different data types can be binded in one particular data type, that is using one particular user defined type, that is struct. So the name of the structure is node, and okay, node is going to hold what information? Data information. What's the data information? It is SSN, name, department, designation, phone number, and then salary. All these information will be there. Apart from that, also this is going to hold the address of the previous node. So previous node is also a structure. That's why the data type is struct node. So struct node star link, and this, as you know, that this field is going to hold the address of the previous node. So address means pointer do exist. That's why struct node star link and struct node star r link. So r link is going to hold the address of the next node. And initially I'm going to create one variable called first and last. And first is why am I using it here is, first is going to hold the first node of the linked list. So always one variable you need to create which should point to the first node of the linked list. Okay, initially before creation, first is initialized as null. Okay, and then I have used one more variable that is called last. So that variable I am going to use to find the last node in the linked list. Okay, next we'll see the get node function. What does get node is going to do for us? Get node is going to create a node. And for that, to create a node you need to allocate a memory. That's why I have here used a malloc function. Malloc function is going to tell that how many bytes. For malloc function you are supposed to tell how many bytes you need to allocate for a particular node creation. So that is why I have defined here size of struct node. Okay, and this is going to convert it into type struct node star. Whatever node you have created need to be of type struct node star, and the name of this node what you have created is temp. Initially the name of the node what you have created is temp, and these fields need to be filled with the proper details. That's why I'm calling scanf function. And how do I access this field? That is by, if the name of this node is temp, then temp arrow SSN. If I want to access name, temp arrow name. So this is how I have to call each field of the node. Then here you can see that I have made temp link and temp rlink is null. So this get node is going to just create a node. So it is not attached. That's why it is always better. If you make this portion, that is created nodes, link portion and right link portion is null. Link portion and right link portion is null. If you make this as null, it is better. Make this as, that's better. Okay. Next we'll see the create function. Create is the first function that is expected by the aim of the experiment. So what does it expect? It's going to ask us it's going to ask the user how many number of elements it want to create. That means how many number of nodes you want to create, and when you call a create function, and then you go on appending the nodes. That's why to append the nodes to a list, you are calling insert end. So here you can see that I have used while function. Why I have used while function? Because I want to create two nodes in a loop. That means for the first, the insert end is going to call a first node when n is equal to 2. If suppose n is read as 2, then what happens? Insert end is going to call when n is 2. That means one node has been created when n is 2. And after calling insert end, then next statement that need to be executed is n equal to n minus 1. So n becomes 1. Then again I will come back to the loop, because the portions within this will be executed until n becomes 0. Next, n is not equal to 0, that is true, as n is 1. So again I will call insert end. What do you mean by that? I will create one more node and attach to this. Okay, and its details will be there, because insert end is going to call in turn this get node function. That way details are filled here. Okay, so here this will be null and this portion will be null. Link for the first node is null. Next, after calling insert end for the second time, n becomes 0. because of n minus minus, n was 1 earlier. Okay, n was 1 earlier and it becomes 0 now. It becomes, because n equal to n not equal to 0, so n becomes 0 now. Now if you try again, go back to while loop and check what happens. Again the n is now n is now 0, so the condition at while loop fails, so comes out of the while loop, and that means you are coming out of the, after that there are no more lines to execute. That means you are coming at the end of the create function. Okay, this is how the create function is going to work. Next we'll see the next function, that is insert front and insert delete. Now before moving on further, I have forgot to declare the variable called temp. Let me declare it in the beginning. So here if you see the getNode function, is making use of temp, and that every new node's name will be temp. Okay, so its declaration is must, so that I have added here. Okay, now we'll continue with the function understanding. So after I have finished create create function, now I will start with the insert front function. So what insert front is going to do? Insert one node in the beginning. So that is, it is going to attach one node in the front. Okay. So there are two cases when you are going to attach a node to a linked list. One is linked list. There is a possibility that linked list may be empty. So when you call insert front, that may be the first node you are going to create. So you have to see two possibilities. What if the list is empty? How we are going to attach? And what if the list is not empty? If there are more than one node. If there are one or more node, not more than one or more node exists in the list. How do we attach? For such a case, how do we attach a node? Okay. So if the first case is list is empty, and one more case is if list is not empty. These are the two cases. That's why I have written here if and else part. So to attach any node to a list, you have to create a node. That's why I am calling a getNode function. So first I will call a getNode function. That means what getNode function is going to do? It's going to create a node. And then insert the informations into it. And the name of the newly created node is temp, that I have declared in the beginning. Okay, name of this is for SSN name and so on, other details, and the last one is salary. So all these details I have inserted, I have created, I have inputted. Okay, and the name of this node is temp. And first let us check what if first is equal to null. So what's the meaning of first is equal to null? That list is empty. If so, make this a newly created node, that is assign the newly created node to a variable called first, because first is now currently it is null. Just you have to assign it with temp. So what happens? Earlier null value was overwritten with the temp address. So what's the temp address? That is, this node's address is assigned to this. So anymore this will be the first node. Okay. Next, suppose what if there are more than one node in the list? What you have to do? Let us assume there are two nodes. Okay, So this one is having this address, and this node's left link is holding this address, and since this is the last node in the list, this will be null and this will be null, and always first is pointing to the first node, that means first is holding the first node address. Okay, let's assume this is 100 and this is 200. What we have to do here, since it is insert front, we are going to, when you call insert front, get node will be called. So that's why one new node you are going to create, and this portion will be null, and the name of this node is temp. Let's assume the address of this is 300. So temp is nothing but 300. Okay, now what you have to do, we have to attach this to this. So that means this portion, temps R link, should hold the address 100. Should hold the address 100. How do we make that? How do we create this link like this? We're assigning, that is, this portion should get 100. That means you are linking like this. Okay, so who is having this node's address? That is first. Earlier first node's address is held by first. So temp R link is equal to first. So that means this one will get the address 100. This one will get the address 100. Okay, let me show that. Okay, when you do that, this one will get address 100. Okay, then is it sufficient just linking this to this? Since it is a doubly linked list, even this nodes this nodes link L link is null because it was the first node. So this one should hold anymore 300. How do we get this node's address? That is, first L link is equal to 300. How do we make, who is having this 300? That is, who is holding the address 300? That is temp. So first L link will be, so now this will be 300. Anymore this is not null. Okay. Next, what else we have to do? I've assigned this address to this address to this, and first is still here. So assigning is done. Then I should tell anymore this is not the first node. This is not the first node. This is the first node. So that's why first is equal to temp. What is temp? That means 300. So this address will be assigned to first. Earlier first was 100. Now first is 300. Next, insert end. So here, what is end? You are attaching the node to the end of the list. So here also the same as earlier, two cases exist. One is what if list is empty, what if list is not empty. So if list is empty, just created node, make it as the first node. Make it as the first node. So that's why, as usual, you create a node if list is empty. This case is if list is empty. Okay, then the newly created node's name is temp. So that itself is first. Just created node's name is temp. So make this itself as first. So how do we make this? So assign the address that is held by temp to first. That's what we have done here. Next, what if there are more than one node? Let us check that. So that's why more than one node, in that case you have to find the last node in the list. You have many nodes in the list. Okay, like this. Now first is here, last equal to, we have to identify the last node in the list so that we can attach newly created node called temp. My temp node is great, just have to attach. Okay, time being this portion and this portion is null. So now what I will do, I will first take a temporary variable called last, and that I will assign it to not that, first address is will be assigned to last. So I will make this itself is the last node currently, and then, so that, because to identify the last node I have to traverse from the beginning, that's why last is equal to first. Then what I will do, until last becomes null, until last R link becomes null. When the last R link becomes null, when you reach the last node, you can see when will be the last R link portion becomes null. Only at this node, it becomes null. Okay, so moment the last R link becomes null, that means you are at the last node. That's why you are doing, while last R link not equal to null, last is equal to last R link. Now in the beginning it is not null, so last equal to last R link. So last has reached here. Next again, this time last R link not equal to null, so last equal to last R link. So last has come here. Next, this time last R link is equal to null, then nothing. The while loop fails, so directly the statement jumps to this line instead of this line. Okay, so we have got the last node. Now our job is to attach. How do we attach? Make this point to this, and that is this R link should hold this address, and this temp node's L link should hold the last node's address. Okay. That is the change you have to do. Now last R link is holding temp. Then temp's L link should hold whom? This node's address. This node is address is held by last. That is what done at this stage. So this is what insert end. Now we'll see the delete front operation on doubly linked list of employee data. So first of all, I have declared here one temporary variables. Okay, and this particular temporary variable t is going to store or hold the deleted nodes information. That is, it's going to hold deleted node address. Okay, that is my aim. That's why I have declared. So that's why I have defined with declared within the delete front function. So first of all, for performing delete front, you need to check whether the list is empty or not. Whether the doubly linked list is empty or not. So how do we check? With this condition. First equal to null. Suppose if the first is equal to null, then you are going to print there are no elements in the list. There are no elements in the list. Now I want to delete a front node, that is first node of the linked list. So that's why I am going to take a doubly linked list. I am going to take a doubly linked list. So let's consider there are three. There are three nodes in the list. There are three nodes in the list, and this is not null and this portion is not null. Only the null portion I am going to declare. I am going to show like this with the line in the diagonal form. Okay, so this is the doubly linked list, and here what I will do, and you as you all know that first will be pointing to the first node. First, or I can tell first is holding the first node address. Suppose this is 100, this is 200, this is 300. First is holding the first node's address. That means it is pointing to the first node. So now what I will do, I will assign this to T, because T is just declared and it does not have an address. And why did I declare this? Because finally it should contain the deleted node's address. Okay, and then I cannot put, after deleting this particular node, I cannot print the node with the first information. That's why what I will do is I will store the first node's information onto T, and then I will check with the rest. Then I will make the certain arrangements. So T is initially pointed to null. Suppose in case of doubly linked list only one node exists, then what happens? This itself is T, okay, and this itself is first, because T is initialized as first, so T will be 100. So first R link. When do you come to know that? There is only one node in the list. You can see here its R link is in this case in this doubly linked list. There is only one node, and you can observe that first R link is null. That means there is only one node. So I am going to check like that whether first R link is null. Then I am going to make first as null. First was earlier holding this address. Now I will make this as null. And this entire memory allocated to this node need to be deleted from the operating system. That's why what I will do, I will make even tr link as null, okay, tr link as null, as well as I will print the T information, whatever fields this T contains, I am going to print, and then I will free the memory allocated to this particular node. I will free the memory allocated to this particular node. Okay, this is about only one node if it is present in the doubly linked list. Next, now we'll see if there are more than one node exists, then what case. So let me come to the else part, first line. So let's assume T is 100. So since I said this portion gets executed only if there is only one node. So else part gets executed if there are more than one node exists in the list. Okay, in the doubly linked list. So that's why what I will do, first already this node's information is assigned to T. So first I will make point to this. So first is equal to first R link. So who is having this node's address? First R link. So this portion is having next node's address. So what is this? 200. So first was earlier 100. Now we should make it 200. How? First R link. What is first R link? That is 200. Anymore, first will be holding the second node's address. Okay. Now since I have made first pointing to this node, now I can remove this node from the doubly linked list. Okay. That's why what I will make is, first of all I will make this first of all I will make, before deleting this node, I will make this portion as null. This portion as null, because as you know that in the first node, L-link portion has to be null. So you can observe earlier this was first node, its L-link portion is null. So now we need, this will be any more a first node, that's why this L-link portion need to be null. So that's what I did. Okay, then now my job is to make this portion as removed by the memory. How? That's why first of all I'll make this portion as null, because otherwise this actually this portion is holding the next address, that need to become null. And then I will free the memory allocated to this. Before freeing the memory, I will just print the details, because after freeing the memory I will not get this information. That's why before that you print the deleted nodes information. This is about the delete front operation or delete front function of the doubly linked list. Next we'll see delete end. In case of delete end, again I will declare one temporary variable called node deleted, which is going to hold the deleted nodes information. Okay, deleted node, before actually I am going to freeing the memory. Before actually I am going to deallocate the memory of the deleted node. I am just displaying its information, deleted nodes information, and then I am going to free the memory allocated to it. That information gets stored in the node deleted. So first is equal to null, means there are no elements in the list. So that we need to check. If suppose there are more than one node or at least one node, what you are going to do? Here what I will do, since it is delete end, we are going to delete the last node from the list. We are going to delete the last node from the list. Okay, so now I am going to delete the last node. How do I identify the last node? I have to traverse from here till the end. So who is going to have the last nodes? Who is going to have the first nodes information? That is first. Okay. That's why what I will do is I will create one more variable called last. And I am going to create one more variable called last, that is declared initially. Okay, so this becomes the last node. Okay, then I will find out the last nodes. How do I find out the last node? That means this last node keep on traversing from one node to another node until the last R link becomes null. You can see that actually last R link, when it becomes null, you have to stop it. That's why you can see here, while last R link not equal to null, last equal to last R link. Moment last R link becomes null, when it becomes null in the last node. So then actually why did I create this variable? To identify the last node in the list. So that's why I did this way. I have used while loop, and I'll make use of last equal to last R link statement until I reach the last node. So first time last is first. When I do last equal to last R link, then second loop last is going to come here. Again this time last R link is not null. So last equal to last R link is going to take the last node position. Next now, the deleted node information that will be there in the last node. That I am going to display. And here uh, before actually freeing the memory, I am going to make some changes. What I will do is this node, last node's information I am going to store in the node deleted. So node deleted is going to contain the address 300 because last is pointing to 300. Then what I will do, last I am going to make it as this node. How do I make this as last node? So node deleted is clear. This will be any more node deleted. Last will become this node, that is 200. Who is having the previous node's address? This portion is having previous node's address. So last L link is going to contain that. Last L link is 200, and after assigning that last L link to last anymore, last will be pointing to this node. Okay, now what you can do, now in this case, if suppose whatever the last node you have got is the only node present in the list, then make, let me repeat again, if the last node whatever you have got is the only node, or whatever you have deleted, okay, is the only node present in the list, then make first as null. Okay, suppose if the last itself is null, that means you had only one node that is present, and make first as null. That means you have to tell there are no more elements in the list. Else, if there are more than one node like this, then what you have to do, make this portion as null. As well as this portion as null. Make this portion as null and this portion as null, and then free the memory allocated to node deleted. That thing you have to do. Okay. And display function is for displaying the status of the doubly linked list. Okay, that means all nodes, that is all nodes information you need to display. That means you are displaying the employee information, because as every node contains the employee data. Okay, and as well as you need to even print the number of nodes that is present in the doubly linked list. Okay, now what is the first thing you have to check? Whether the list is empty or not. So if so, you have to display list is empty and you can return. Suppose there are more than one element in the list, then what you have to do? So initialize this that is first node address to temp, because you know that first node is always pointing to the first node. So now temp will be initialized with first node's address. Then I will display the header. Okay. Then I will make count as 0. Then consider count as 0. Okay. Now I will check whether temp is equal to null or not. Temp is not equal to null, right? Temp is not equal to null. If so, because temp is having address 100. Okay, right now first node's address is 100. So temp is not equal to null. So then print temp, that is first node's detail. Print first node's detail. It's SSN information, name information, department, designation, phone number, salary, everything you need to display. After that, what next? Next is temp equal to temp rlink. After displaying this information, temp should take the next node's information. How do we get the next node's information? This field is going to contain the next info, that is 200. So that address we need to assign it to temp. Temp should be equal to temp rlink. Temp rlink is 200. 200 will be assigned to temp. Earlier temp was 100, n more temp will be 200. Now temp is not equal to null, so print this node's information, print this node's info, right? That is this employee's info, and then make temp equal to temp r-link. So this time temp r-link is null, so temp will get null value. Temp will get null value. So again while loop, we are going to check whether temp is not equal to null or not, but this time temp is null. So it comes out of the while loop, in the sense directly to this line. So in this line, as in the while loop, whenever you are traversing through each node, count was also getting incremented. That information, the count information, we are going to display out of the while loop, because you want the final count. That's why once the while loop terminates, you are going to print the number of nodes information. That is in this case it is 2. This is about the display function. Okay, next I will explain the implementation of a doubly ended queue. Okay, so W-ended queues name I have given as queue. Okay, and here I have used a while loop and switch case, because as the W-ended queue can take all the operations like insert front, insert end, delete front and delete end, and then display. That means the W-ended queue in the both the sides we can perform insert front and insert operation, and as well as delete operations. Both the sides you can perform insert as well as delete operations. So that's why I'm displaying the menu for a queue, and then I'll ask the choice for it, right? And then switch choice, that is you have to opt for in the menu you have to opt for a one particular choice at a time, and then accordingly it is going to execute either insert front, insert end or other operation. Okay, that's about the doubly ended queue. Next we'll see the main function. In the main function, first I have declared choice into choice. Okay, and then first I have declared choice into choice, and it is initialized as 1. Okay, then if until choice becomes 8, the while loop will be executed. What is choice 8? 8 is exit. Okay, then until you prefer to exit, these set of menus will be keep executing. You can execute one after the other. Okay, there are several choices. One is create, next is insert front, delete front, display, insert end, delete from end, then DLL as queue, and exit. Okay, suppose if you enter your choice as 1, okay, that is read because of the scanf function. Okay, and then suppose enter the choice is 1, then create function will be called, otherwise insert front function will be called. Next, delete front will be called for case 3, that is if you enter a choice 3. Next, fourth choice is display, fifth choice is insert end, sixth choice is delete end, and seventh choice is WQ operation. So once switch case is done, then you are going to end the switch case, then outer loop for switch case was while, so while loop you need to end, while ends here, and finally at the last main ends. So this is about the program. This is about the doubly ended list program. Next we'll see the execution of the program. I am here executing the program in the TDM GCC compiler. So that's why I have here opened the command prompt, and now next what I'm going to do, I'm going to run the program. The program name here I've given is DLL. So let me show the program. So this is the program. Next I'm going to compile the program, GCC compiler like Linux, GCC program name dll.c -o, store the output in DLL file. Then I'm going to run the DLL file with start DLL. Next I will show the output. Okay. So first I will try to create at least 2 nodes. So that's why I have entered the choice 1. So here I will tell how many nodes I am going to create. I am going to create 2 nodes. Next I will print the SSN. I will enter the SSN information of an employee, that is 1, and then the name of the employee, that is XXX. Let me take AAA, and the department, tell ISC. Next designation and phone number. While entering I pressed twice, that's why it went to next one. Then phone number something I will print. Next salary, some number, random number I'll give. Next I will enter the another person's detail, name BBB, department ISC, designation assistant professor. Next salary something. Okay, you can see now I will display the content. You can see here by mistake I had pressed colon, that was taken for the department option. Okay, that was taken for a department for the first employee. Next I will perform insert front. Enter your choice. SSN I'll give 0. Then name I will give CCC. Department I'll give ISC. Designation I will give associate professor. Next phone number and it's given as semicolon by mistake, and then salary I will give it as some random number. So let me display the content so you can observe. So CCC ISC associate professor, sorry, as I had given space here, that's why it has taken for the next one. So that's why don't give space while writing the information. Okay. Next, if you while entering the informations of an employee, if you give a space, it will be the next information will go to the next field. Okay, that is what happened in my case here. Next, I am going to delete an information. 3, delete front. So you can see that first information got deleted. One more information I will delete. Okay, and again I'll perform delete front. 3. Now so all the details got deleted. From the linked list. Now if I again press 3, you will get the information no element. Now I will perform insert end. 5. So again it will ask for the information. Let me give in SSN4, the name I will give SSS, department I will give SESC, designation I will give, I will not make the mistake of giving space this time, associate, enough. Okay. Next, phone number I will give as some random number, salary some random number I will give. So again one more time I will perform delete and operation. 5, next time 5, name something, department ISC, let me give CSC, next designation assistant professor, then phone number some random number, salary some random number I'll give, then 4, display, you can see the information, and then I'm going to now perform delete from end. So first time when you perform delete from end, the last element, last row need to be deleted, should get deleted. So you can see here the last information got deleted. Again if you perform, the one which is remaining will be deleted, that is the SSN, that is the employee information with SSN 4. So you can see here employee SSN with 4 information got deleted. Now if I perform 6, again if I type 6, then what happens? You can see that there are no elements. Okay, and now similarly you can try with the DLLSQ. Okay, and the implementation in the exam on DLLSQ is not necessary. You can using these functions you can show, demonstrate, otherwise you can implement and show. Exit, how do you perform exit? That is just by pressing 8. You can see here again I have come back to where I had left it off. So this is about the 8th program of data structure laboratory.